Dear students, in this video we'll study an important application of circular doubly linked lists, that is the addition of long integers based on the approach which is explained in the textbook. Note that this example is very important not just because of the arithmetic involved in it, but because it clearly demonstrates why a particular data structure is chosen and how it simplifies complex operations. Okay, so before moving ahead, first we need to understand why long integers need a special representation. See, in many or in most of the programming languages, integers are stored using fixed size data types such as integers, float, double, long. When we use this approach, there is an upper limit on the size of the integers that can be represented. For example, integer has it has 2 to the power of 32 as a limit, right? In C programming language or in any typical programming language. However, many real world applications require us to work on very large integers. For example, you take cryptographic computations, symbolic algebra systems, arbitrary precision arithmetic. So to overcome this size limitation, we need to represent integers using a different method, not using the traditional or the conventional data types. There comes the idea of representing numbers using linked lists. So the idea is like this: instead of storing the entire number in a single variable, each node of the linked list stores a portion of the number, and the number of nodes keep on increasing as the number of digits increase. So this approach gives us a dynamically sized integer representation. Okay. Next, definitely an important question comes as to why do we specifically use a doubly linked list? Yeah. So if you see in this particular application, you are performing two major operations. One is the arithmetic operation itself, and second one is that the problem statement goes like this: you have two numbers, let's say number p and number q. So you're going to subtract the smaller magnitude number from a larger magnitude number. So you need to identify a number with the highest magnitude or highest absolute value, or the larger absolute value between the two numbers, right? So in order to do the comparison of the magnitude, that is also another operation, correct? So both the arithmetic operations require traversal around the linked list. So when it comes to addition and subtraction, you always started from the least significant digits and you move towards the most significant digits, correct? So that is one type of traversal where you're going from LSDs to MSDs. Whereas the second operation, that is the magnitude comparison, you move from most significant digits to the least significant digits. So you're traversing both the ways, okay? And if you were to use a singly linked list, you should know that a singly linked list, it supports traversal only in one direction. So that's why a doubly linked list allows you to traverse in both the directions. This is what we exactly need, and that's why we use a doubly linked list. And also, to avoid special cases at the beginning and end of the list, we use a circular doubly linked list with a header node as well. Okay. Now, how do we represent our long integer? Okay, so each long integer is represented as a circular doubly linked list consisting of one header node and zero or more digit nodes. That means each node consists of part of the larger integer. Okay, so and the node structure would look like this. Each node consists of a pointer to the previous node and an info node and a pointer to the next node. So the previous node is represented here as left and the next node is represented as right. You can it's just a programming convention. You can use your own conventions. That's not a problem. Okay. After this, the very important concept that comes is of the header node. Why header node is special for us is because it does not just store any digits, but what it does instead is the info field of the header node stores the sign of the integer as well as the number of digit nodes. Okay, how let's take for example, if the info field is positive, that means it's greater than 0, that means it indicates that the entire number is positive. If info field is less than 0, that means it indicates that the integer is negative. And the absolute value, that means without the sign, whatever value you have in the info field, it states that the total number of digit nodes, that means total number of nodes in our linked list. Okay, so for example, info field of your header node has -3. It indicates that the number is a negative number and the number is stored using 3 nodes. And if you have info field as 2, that means it's a positive integer, and we used 2 nodes to represent the total number or the complete number. And info 0 implies that the integer value is 0. Okay, now let's move further and let's see how we store the digit nodes and the base representation. Okay, so each node, if you are already aware that it does not store a single decimal digit. Instead, it stores a group of digits using a fixed base. And in our case, the base what we have used is 100,000, that is 10 power 5, or simply it's 1 lakh. That means each node consists of a 5-digit number and the value ranges from 0 to 99999. Okay, so why this approach is because when we do the digit grouping, it reduces the number of nodes, it improves the efficiency because you have fewer number of additions to be done because you are going to add them node by node, not digit by digit, and yet it preserves the correct arithmetic behavior. That means number of additions are going to get reduced, but still the answer is going to remain the same. Okay, so if you have seen the textbook, for example, you have this example, right? So how do we exactly represent is, you can take it from here. So the first diagram, it explains how each node consists of the left pointer and the info field and the right pointer, and you can see that how the integer -324 2197849 9762 is stored. So you see that you start storing it from the least significant digits, 5 digits, 497 62 in one node, then 21978 in another, and the remaining 3 digits 324 in the last node. And the header node consists of 3, meaning that 3 nodes are there that have been used to store the digits in the entire number, and minus indicates that it's a negative number. And similarly, the second example you have is the integer 676941. So 76941 is stored in node 1 and 6 is stored in node 2, and the header has value 2 indicating 2 number of nodes, and plus meaning that the number is positive. And integer 0, this is 0 is treated as a special case that indicates that the list contains only the header node and with the info as 0. Okay, fine. So yeah, so we need to understand as to why do we need the comparison of absolute values. So if you remember, initially we had discussed the problem statement that you're going to subtract a smaller magnitude number from a larger magnitude number, correct? So let's say you have two integers. If both the numbers have the same sign, that means the operation becomes the normal addition. But if the numbers have different signs, let's say you have one positive number and another negative number, then addition becomes subtraction. So in case the second case, that means when you have different signs, you need to subtract the smaller absolute value from the larger absolute value and assign the sign of the number with the larger absolute value to the result. Okay, so that's why the absolute value comparison is essential. So for this purpose, we have to write a function called as compabs for comparing the absolute values. Okay, so the function looks like this. Okay, the function compares the absolute values of two long integers. The two long integers are stored in node list P and list Q. So, and initially it would be pointing to the header nodes, correct? So it checks the headers info field. If P's header field has greater value than Q's header, then it is going to return 1, meaning that number of nodes in P are more than the number of nodes in Q. That means P is a larger value, so it is going to return 1. Else, if the number of nodes in P are lesser than or fewer than the number of nodes in Q, it is going to return -1. In essence, the entire function has 3 possible outcomes. It's going to return value 1 in case the first number is larger, and it is going to return -1 in case the second number is larger, and in a very rare condition it's going to return 0 if both the numbers are equal. Okay, so this is the essence, correct? So first it compares the number of nodes. If the number of nodes are equal, then this part of the function comes into picture. Okay, so in here what happens is, so you are pointing to the header node, so you move to the left side of the header node. So what do we have at the left side of the header node? We have the most significant digits. So we start comparing with the most significant digits of number 1 with the most significant digits of number 2. So there you are going to compare the absolute value if the absolute so that's why we have used two pointers, pointer R and pointer S. Pointer R points to the digits of number 1 and pointer S points to the digits of number 2. Okay, so it is going to compare it this way. So let's say this is the header node, right? And this is the header node. This is number P and this is number Q. So we move to the left side, meaning that we are pointing it here at number 3 to 4 and we are pointing at number 6. Okay, this is R and this is S. Okay, so what we do is we compare the value pointed by number pointers R and S. So if R is greater than S, then we return 1. Else, if that means if R has lesser value than S, we are going to return -1. Okay, let's say if both the nodes still contain the same number of same values, then we're going to move to the next node. That is, instead of pointing at here, we point it at here, and next time we point at this place. Okay, so this way the comparison has to happen. Okay, so the comparison keeps on happening until we find the difference. Okay, so if the counts differ, then the decision is immediate, meaning that you either return 1 or you return -1. But if the counts are equal, you traverse the list from most significant digits and you compare digit groups one by one till you encounter the least significant digits. So once you encounter least significant digits, even the least significant digits are also same, then it indicates that both the absolute values are same, and in that case you are going to return 0. Okay, so just to summarize, you compare the first in this point where there is compare counts. So you compare the number of digit nodes using the header info. If the count differs, the decision is immediate. Otherwise, if the counts are equal, you traverse the lists from most significant digits and you compare group by group till you find the difference. So if there is a difference in the values, the decision is again immediate. You return 1 or -1. Otherwise, you keep on traversing, and then if till the end also, if the number of nodes are same, if the values in each node is also same, then it implies that the absolute values are equal and you return 0. Okay, so this is about the comparison. So this one tells us that which number is larger and which number is smaller. So this is a very important function, because after this function is called, you know which number to be subtracted from with the other number. Okay, fine. So the next point that comes is the subtraction part, correct? So let's say if both the numbers have different signs, meaning that if one number has positive sign, another number has negative sign, in that case, how the arithmetic happens? For that purpose, we write a function called as addiff, and it takes two parameters, that is the pointer to the number. There are two pointers, one is pointer P and another one is pointer Q. Pointer P points to the number with the larger absolute value and Q points to the number with a smaller absolute value. And just for your information, how we found the larger absolute value and smaller absolute value using compare abs function. You have seen it previously, and this function is going to return a pointer to the header node of the resulting integer. Okay, so after this, what we need to just before looking into the function exactly, recall how manual subtraction happens. So if you do any arithmetic operation, you do either it's addition or subtraction, you do the subtraction or addition of digits from right to left. Okay, so let's say I have number, okay, I have number 4 and I have number 8. Okay, so I want to subtract 8 from 4, correct? So in that case, what happens in this particular scenario, the top digit, that is 4, is smaller than the bottom digit 8. So what we do is we borrow from the next higher digit, correct? So in that case, what you do is you take 1 and then you subtract from it, and then what is the result you have? You have the result as 6, and borrow, you have it as 10, or and then you do minus, right? So this is how the result of 4 and 8 is, right? It is minus 4, right? So borrow always flows from higher digit to the lower digit. So in our implementation, we are not using the base 10. We are using the base 10 power 5, meaning that borrowing now implies that you are borrowing 10 to the power 5. Okay, 10 to the power 5 from the next higher digit group. Okay, so these are all the variables what have been used. Okay, so after that you create a new header, basically you create a new node R. Okay, so which is going to store the result, and initially it's pointing to itself because the result list is currently empty. It has just one node and each of them pointing to themselves, correct? And then you start the traversal. So the traversal starts from least significant digit, and just to recall, the least significant digit is always located to the right side of the header node. So that's why you are incrementing the pointer to the right side, not to the left side. Okay, so what you do is you're going to run the loop as long as the nodes exist in the smaller number. Okay, because let's say if larger number has been represented using 3 nodes and smaller number is represented using 2 nodes, the loop is going to run only for 2 times. Okay, so that's why you run a loop till the number of nodes exist in the smaller number. Okay, that's why if q pointer is not equals to q, and this is the very important line. What it does is it subtracts the digit group from q. Okay, so you have number p, okay, number from group p, and you subtract the number from q, and if there exists any borrow from the previous step is also subtracted. So that means simply you can say that the difference is p minus q minus borrow. Okay, so now how do we handle the borrow? So if the difference that has been calculated at this step is negative, then what do is we add the base value to correct the digit. Okay, and we set the borrow as 1 for the next iteration. Okay, see, if it is a negative number like you saw it previously, what you do is you're going to add the difference to the base, and then the borrow is set as 1. Okay, so if you can just recall, you have 4 and you have 8. Okay, so 8 cannot be subtracted directly from 8. So what you do is you take a borrow of 1. So then what is the value? You have the value 6, correct? And then what you do is the borrow. You keep the borrow as 1. And then next time what you do is you do 10. Okay, then you have the value 6, then minus 10. So you get the final answer as -4. So this logic has been put here. Okay, so let's take another number. Let's take a larger number this time. Okay, so you have a number, let's say 1 0 0, another 0 and 2, and you subtract 9 from it. Okay, so in the 10 power 5 base representation, how it becomes is you have 1 and then you have 2, and this one becomes 0 and 0 0 0 9, and this one becomes like this, correct? So subtracting the least significant, this is the least significant digits, right? So subtracting 9 from 2, you get it's negative. So what you do is you borrow 1 from like 10 to the power 5. So what it becomes is, it becomes something like this: 1 0 0 0 2 minus 0 0 0 9. Okay, so what it results is, it results into 99993. Okay, so the next digit becomes, the next digit is this one. Okay, and you had a borrow which we had borrowed all previously, so it becomes 1 0 0 0 minus 1 0 0 0 0, so it becomes 0. So this totally becomes 0 0 0 and 99993. So your final answer is 99993. Okay, so this logic is in the else part. So if the difference is already greater than or equals to 0, then you are going to reset the borrow to 0. So that's not a problem. Okay, and whatever resultant digit group you get, it's inserted to the left side of the header. Okay, so this way you preserve the correct digit order, and so that's why we have a insert left function. So where the reference to the head node is given, and the new difference whatever you obtained at this step or after updating at this step you insert that value to the left side and you increment the number of node to by 1. Okay, fine. So then next, if you see, for example, in this scenario, in this case, we had a node where it contained all zeros, and these were the leading zeros, correct? This was formed as a result of the subtraction operation. So if a node exists with all leading zeros, it has to be deleted. Okay, so for that, in order to delete the leading zeros, what you do is, if the difference is 0 and we have taken a boolean flag called as 0 flag, it's initially set to false. Okay, so in that case, while inserting the node, we make the 0 flag as true. Okay, and then we keep advancing the traversal pointers to the right side. Okay, so that means till now whatever happened from this point, difference to this line, so this was for one set of nodes. That means one node from number P, another node from number Q. Okay, so next we need to advance our traversal to the next node. So that's why we move to the right side. So we are incrementing here. So the loop continues, and after that, then you remember we had used the loop to be run to the number of till the number of nodes in the smaller number. So that means the larger number would still contain some nodes. So we need to process the digits from the larger number after the smaller number is exhausted. In that case, what you do is you just simply you subtract the borrow if it is, otherwise you keep on adding. Okay, so that is for this while loop is for the remaining part of the larger number, and there also the logic is same. If the difference is greater than or equals to 0, that means borrow is 0, else you're going to add the base and make the borrow as 1. You're going to insert the difference to the left side and increment the count by 1. And if any node becomes a node with all zeros, you're going to set the 0 flag to true, and you advance the pointer to point to the next node. Okay, so after this, so we keep on collecting all the nodes that have all the leading zeros. Okay, so in that case, what you do is, if the 0 flag is true, which we have set here, so you keep deleting such nodes and decrement the count of nodes by 1. Okay, why? Just to adjust the canonical representation. Okay, see, there is no point in storing my node, my result like this, right, with two nodes, one node consisting of all zeros and another node consisting of non-zero values. I can store only one node with the exact result. So that's why, to preserve the canonical representation, you're going to delete the leading zeros. Remember that we are not deleting the trailing zeros. Okay, if there existed a scenario where after this we had 0 zeros like this, no, we are not doing that. These zeros are still valid, they have meaning, but only the leading zeros must be deleted. Okay, and then finally what you need to do is, see, if you remember, we are creating new nodes in the resultant list, and we keep on adding the values, but the header node is still empty. Okay, so in that case, after all the nodes have been filled, the header node of the resultant list has to be updated. Okay, so there, if you remember, the sign of the result is same as the sign of the larger list, correct? So larger list is P. So if P has a value P of info, that means P's header consists of a value greater than 0. That means the count whatever you have done in the result, that is you store it as it is. Otherwise what you do is you store it as minus count, indicating that the number of nodes and the result is minus value, or the result is a negative number. Okay, for example, you have a number like this. See, you have a number like this. Okay, so you might have got some value. So this is a, in this case, B is a larger value, correct? And the result of whatever you have, you would have got the count as to how many nodes were required to store the result value. Okay, so that count and the value of the sign of the larger number is stored. Okay, in this case both are negative, the larger magnitude value is also negative, so the sign of the larger magnitude number is preserved. Okay, so that is taken care here. Okay, so absolute value result sign is, just to simplify it, result sign is same as the sign of P. Okay, that's why you are comparing P. If P of info is greater than 0, then R of info is also count. Otherwise, if P of info is less than 0, what you do is minus count. Okay, and the absolute value of info is the number of digits which are stored using the count. Okay, and you finally return the pointer to the header node of the result. And in here you can see what all variables we have used and what is their purpose. Okay, so this function is all about the addition of numbers using when you have different signs, that means one positive and one negative. Okay, so let's say in case of a scenario where the signs are same, that means if either of them are if both of them are positive or if both of them are negative, in that case what happens is, see, this kind of this method you would have already seen when you would have added you would have seen the application of circular singly linked list, where addition of long positive integers was explained, right? So there you are just going to add the, when both the numbers are the same sign, that means the operation is simple, right? You perform node wise addition with the carry propagation, and of course the traversal starts from least significant digits to the most significant digit, and each result digit or the result node is inserted to the left side of the headers, and that means the order is preserved automatically. Okay, so just to recall, carry is like sum divided by the base, that is 100,000, and the sum that is going to get stored in the result is sum mod the 100,000. Okay, and even though if you see, all of the operations remain same. Okay, in the last side you have the finalization of the header node. Okay, so even though both the operands have the same sign, the result list is created newly. That means the header info is still empty, so you need to fill in the value. So that's why you need to give the correct sign and number of digit nodes. So the number of digit nodes is given by the count, and the sign is again like you do it from the p of info. So if p of info is greater than 0, that means the result is positive, otherwise the result is negative. Okay, then after these two methods, the first method addiff is for when the signs are different, and then you have the addsame function, that is when you have the same signs. Yeah. In the last part, we had discussed about the addition of numbers when we had different signs. Now we'll quickly look into the addition of positive or negative integers. That means when both the numbers are either positive or either negative, correct? Or to put it simply, when both the numbers have the same sign. So in that case, we write a function called as addsame. So what this function does is, it makes the operation very simple because you have both the numbers have same sign. So it's just that the digits have to be added, that's it. And when you add, then definitely there is the concept of carry propagation, and the traversal starts from least significant digits to the most significant digit, and each result digit is inserted to the left of the header, so the order is preserved automatically. So this function is more similar to the method what you might have seen in the application of circular singly linked list, where you added two long positive integers, right? So a quick walkthrough of this function is like this. Again, you have two pointers, pointer p and q, to represent first and second integer respectively, and this function also returns the pointer to the header node of the resulting integer. And here also you create a result node, and you initialize it, and you traverse to the right side, that is you start with the least significant digits. Okay, and the loop is like either of them has some some nodes, some node left, you keep on adding the corresponding digit groups. Okay, so here you do digits at p plus digits at q plus if there exists any carry. Okay, and how do you calculate the new carry? You do the sum divided by 100,000, and the sum that is going to get stored is the sum mod 100,000, and whatever sum you have at this step, you are going to store it as a result digit node, and you are going to insert it at the left side, and you increment the count by 1, and you advance the pointers to the right side again. Okay, and let's say if one of the nodes has one of the lists has more nodes than the other, you're going to do the same operation. And finally, if there exists a carry, then you're going to increment the carry as well. You're going to insert the carry as well and increment the count of number of nodes by 1. And finally, you define the header node. So the result sign is same as that of the operands, that is we consider it as p. You can even consider it for q as well, it doesn't change. And the absolute value of the info field is nothing but the number of digit nodes which you are tracking using the count variable, and you return the pointer to the head node of the result node. Okay, so you saw one function where the addition had turned into subtraction because both the numbers had different signs, and one function where both the numbers have same sign, so it's nothing but the addition, and the magnitude the sign is going to be the same as that of the highest value. Okay, now what we can do is we can write a master addition function called as addInt. So what it is a it's a controller function. It does not do any arithmetic by itself. So what it does is it first checks whether operands have same sign or no. Okay, in that case what it does is if both of them have same sign, that means p and q both have same sign, then it is going to call the addsame function. Otherwise what it does is at this step it compares the absolute values of the numbers, okay, and calls the addiff function with the arguments in the correct order. Okay, so you see you're comparing p and q. Let's say if p turns out to be a larger value, so you call the addiff function with p and q, that means q is subtracted from p, and otherwise the addiff function is called with q and p as parameters, meaning that p is subtracted from q. Okay, and this one same sign, how do we identify whether both the numbers have same sign or no? See, you have, let's say you have two numbers p and q. If both of them are positive, that means p is also positive and q is also positive, or if p is also negative and q is also negative, the multiplication of p and q gives you always a positive number, correct? See, when the signs are different, let's say one is positive and another one is negative, that time multiplication always gives the result is always a negative value. So that way what you do is you do p of info and q of info, you multiply. So p of info and q of info is the header node where in the list the info field of the header node. So there you would store the number of nodes and the sign. So if you see plus and plus, plus multiplied by plus gives you the result as plus. See, plus multiplied by plus gives you plus, correct? If you multiply minus into minus, also you get plus. The other condition, that is plus multiplied by minus gives you minus, or minus multiplied by plus gives you minus. So this way, that means if the result is greater than 0, that means it indicates that it's a positive number. Okay, that time you call the addsame function. In the other case you call the addiff function only after the comparison. So addInt is your main function. Based on the signs, it either calls addsame or addiff. Addiff is called with the correct order of parameters p or q or p based on the value returned by compabs function. Okay, so this is the complete flow for the addition of long integers using circular doubly linked list. Okay, so just to quickly visualize how does the addition happens, I can take some examples here. So let's say you have this number. Okay, so this is one number and this is another number. So you can see that A has 3 nodes and the header node has +3 and the values are stored this way. B also has 3 nodes, then the values are stored it this way, and since both of them have same sign, so we call the addsame function, and each time the values are added node by node and you get the final result. Okay, and now let's take another example where you have this one where both the numbers are negative. In that case, what happens? Okay, so this time header node consists of value 3 but the sign are minus, but still both of them have same sign, right? So there you still call the addsame function and you keep on adding the values from the nodes and the result is stored like this. Okay, now we'll take the third case where one of them is positive and another one is negative. Okay, so in this case what happens? A is positive, B is negative, so we need to call addiff function and the addition in turns to be subtraction here, and you're going to subtract node by node and the result gets stored this way. Okay, you can see that you have this node but it has meaning because the most significant digits are this one, this. So this node cannot be deleted just because it has all zeros, because it contains meaning. If this 0 node existed here, then it could have been eliminated. Okay, and we'll see a final example, this one, where the magnitude is, this one has minus sign and this one has plus sign. Okay, so in this case what happens? The signs are different, okay, and the subtraction happens, but magnitude of the sign of the larger number is minus, so the final result will also have the value minus. Okay, so this ends the video. So we have made a quick walkthrough of the addition of long integers using circular doubly linked list. I hope you have understood the concept, and thanks for staying till the end of the video.